Cloud SQL, and we are going to see today BigQuery. So Cloud SQL is a more of an RDBMS solution, which is an operational database or a transactional database. You can think of like a OLT. BigQuery is more of a OLAP, which is an analytical database or a data warehousing solution. Okay, let us try to understand what is BigQuery and how to work with a BigQuery. So let us see. For example, if I go to the BigQuery, so this is how the BigQuery looks like. I'm going to enable the API for the BigQuery. So BigQuery is one of the modern data warehouse. Very, very important thing is that it is a serverless platform. It is a serverless. So it is a serverless platform. What do you mean by serverless is that, for example, if you remember, if you wanted to work with a Cloud SQL, what is the thing that we have done, sir? Can you tell me? What is the first thing that we have done in the Cloud SQL? Correct. So, so if you wanted to work with a Cloud SQL, the very first thing you need to do is that you need to create an instance. Okay, an instance is nothing but a server. You are just trying to create some kind of a server. On top of the server, you can able to create your databases, tables, and all of those things. Okay, so you are trying to create an instance or an environment or a server so that you can able to work with that. Similarly, in the BigQuery, it is a serverless platform where you don't need to create any server at all, because you can just directly go for creating your database and tables and views and functions. So that is the reason it is called as a serverless platform. For serverless platform, no need to create any instance or server or any environment. You don't need to create anything, guys. You can directly go for the development. So that is the main important thing about the BigQuery. Okay, so it is called as a serverless platform. It's because you don't need to create any instance. You don't need to set up any server. You don't need to create any environment. No need to take care of the configuration. No need to take care of no configuration required. Okay, no configuration required, guys. Because in the Cloud SQL, if you wanted to create an instance, you need to provide the configuration. This amount of the RAM, CPU, storage, the version, you have to select all of those things. But with the BigQuery, everything is automatically managed. Nothing need to be taken care. So that is the reason it is called as a serverless platform. Okay. The second point is that it is a data warehousing solution. Okay, what is this one, sir? It is a data warehousing solution. So in Google Cloud Platform, if you wanted to work with large amounts of data, and if you want a data warehousing solution, you can go for the BigQuery, because BigQuery is a data warehousing, or you can also call it as the analytics services, analytics solution. So it is one of the modern data warehousing solution or analytics solution, guys. Okay. So when I say when I say BigQuery, what kind of a data we can store it here, sir? In a BigQuery, we can store structured data, sir. Structured data. which is in the form of a tabular format. When I say tabular, you will be having columns and rows, and the schema is must be defined properly. Schema defined, schema is must. Okay, so this is what is a BigQuery, sir. In BigQuery, what kind of a data we are going to deal with? If you ask me, so we are going to deal with structured data. The data which is in the form of a tabular format, which will be having columns and rows, and the schema is must. We have to must be define the schema. Okay, so that is our third point. And fourth point is that, sir, for example, if you wanted to work with large amounts of the data, we can able to go with the BigQuery as I told you, because BigQuery is one of the big data solution. It is one of the big data solution because you can able to work with large amounts of the data here. Sir, I have a very large amounts of the data. Can we able to work with BigQuery? Yes, because it is one of the big data solution. You can able to work with the large amounts of the data. Okay, so that is how it is, guys. So whenever you wanted to work with large amounts of the data, you can again go to the BigQuery. So that is something again one more point. Sir, what kind of a language that we can use it here? Sir, for example, I wanted to create a database, create the tables, and create views, all of those things, insert the data, all of those things. So can you tell me in BigQuery what kind of a query language we can use? Does it come up with a query engine or not? Yes, sir. BigQuery comes up with a built-in query engine. The BigQuery comes up with a built-in query engine, guys, which is capable of running SQL queries. Okay, so that is what it is, guys. Okay, so BigQuery comes up with a built-in query engine which is capable of running SQL queries. So here the SQL is called as a standard SQL. That SQL is called as a standard SQL, sir. Okay. So in a BigQuery, whatever the SQL that you are using, it is called as a standard SQL, which is actually similar to 95% is similar to your the SQL that you are using every day. Okay, so BigQuery comes up with a built-in query engine, which is capable of running the SQL queries. Okay, and what about the performance? Or are we going to get a very good performance or not? So we are going to get a very good performance. Terabytes of the data we can able to manage within seconds only, and petabytes of the data we can able to manage within a minutes only. So if you wanted to insert the data, terabytes of the data within few seconds, or petabytes of the data within few minutes only, you can able to do it. And do we have to create the infrastructure here? We don't need to create infrastructure. No infrastructure creation. And sir, if I wanted to increase the performance, and if you go to the traditional warehouses, if you wanted to create the, if you wanted to increase the performance, what they're actually doing it, they are actually creating the indexes to increase the read performance. Right? In the traditional warehouses, if you wanted to increase the read performance, they are going to create the indexes. But in the BigQuery, no need to create any indexes, because there is no concept of indexes at all in the BigQuery itself, because you are going to get a very good performance without creating any infrastructure itself and without creating any indexes itself. Okay, so why? Because BigQuery follows a columnar storage model. Okay, how the BigQuery stores the data? Sir, BigQuery stores the data in a columnar storage model. It follows a columnar storage model. That means it stores the data in the columns. So, for example, when you go to some traditional warehouses, as if you go to some RDBMS solutions, how the data is stored is that, for example, if you think that this is a small table, if you think that this is a small table, the data is stored. For example, it is a ID column, name column, salary column, age column. Okay, so in the traditional systems, the data is actually stored. Okay, one, some Ravi, some salary 1000, age some 25, some two, comma, 2026. Look at here. If you go to the traditional systems, so what happens is that traditional systems follows the data model as a row storage model. It is a row storage model, guys. So when I say row storage model, the data will be stored in the form of a rows. Row by row, the data will be stored. For example, if you go to the row storage model, the data will be stored like this. This is one row. First, it will be stored here. And the next row, it will be stored here like this. So row by row, it will be stored. If you still wanted to see it, you can just write one more line. Okay, so let us take one more record also. So look at here. When you go to the traditional systems, the data will be stored in the form of a row by row, sir. First row, it will be storing the first row. And the next, it will be storing the next row like this. Okay, so after that, the third row will be stored. So this is how in the traditional systems, the data will be stored in the form of a rows, row by row. So first row stored, next row is stored, third row is stored. It is called as the traditional system. In the traditional system, the data is stored in the form of a rows. So that is the reason it is called as a row storage model. Okay, so in a row storage model, that most of the times when you go for row storage model, the inserts modifying the data is more faster. Inserts are more faster than the updates. Sorry, inserts are more faster than the reading. So that is the reason if you go to some RDBMS solution, we don't use it for the analytical purpose. It is because they are not much faster for the analytical workloads, because their main purpose is to support the business so that they can directly insert the data mainly. Okay, so that is how the traditional systems are designed for. So here the data is stored in the form of a row by row. So this is called as a traditional working model or a row storage model. But when you go to the BigQuery, how it stores the data, sir? If you go to the BigQuery, the data is actually stored like this. Column by column. It is going to be stored. This is column 1. This is column 2. Column 3. So this is how in the BigQuery the data is stored. Column by column it is going to be stored. First column will be stored, the next column will be stored, the fourth column will be stored. This is how in the BigQuery column by column the data is stored. So first column, second column, third column, fourth column. Now tell me, if I wanted to get the maximum salary, do I need to go for the traditional system or the BigQuery columnar storage model? Can you guys tell me? I wanted to get the maximum salary, guys. Which is very fast? Row storage model or column storage model?
Column storage.
Okay, try to understand it why it is column storage model. Because whenever you wanted to tell me how to get the maximum salary, guys. What is the command for getting the maximum salary?
Salary from a table.
Max of salary, right? Select max of salary, then you will be able to get the maximum salary, right? Select maximum salary. So So to get the maximum salary, you don't need the ID column, you don't need the name column, age column, you don't need all of those things, and you don't need to read the entire table. For example, when you wanted to find the maximum salary here, you need to scan the entire table, the because here one record here, one more record here, one more record, such that you need to get the salary column. First, you need to scan the entire data, then you need to go for the salary column, and then you need to get the maximum value. But here it is not like that. You don't need to scan the entire table. You can just scan the salary column, then you can get the maximum salary. So that is the reason row storage model is mainly for reading the data. Row storage model is mainly designed for reading the data. That means analyzing the data. So whenever you read it, you will be able to analyze it. So analysis will be very faster in the BigQuery because it is a following the columnar storage model. Okay, it is following the columnar storage model, guys. So that is the reason the BigQuery is very, very faster for reading the data or analyzing the data. Okay, so this is the main difference. Okay, so that is how sorry guys.
How does it link the columns? Like, the columns are separated by independent, right? So how does it link? Let's say I want to get a shop.
It will be having its own way of linking the data. Okay, so maybe it stores the data in the form of a capacitor, and it is well aware of that. It is a single table, and it matches the entire data. Okay, so we don't need to worry about that. For sure it is a tabular data only, but in the back end, when it is actually splitting the data, it is going to be splitting the data based on the column instead of on a row. Okay, yeah, sorry. So that is how BigQuery stores the data in the form of columns, guys. And one more interesting thing about the BigQuery is that, so if you go to the traditional systems can only do the batch data analytics, but you cannot be able to do the streaming data analytics. But BigQuery is that it is also provides both batch data analytics plus streaming data analytics. So you can able to perform both of these things, guys. That is the best thing about the BigQuery. So with the help of the BigQuery, you can able to do the batch data analytics as well as streaming data analytics. So that is one more thing about the BigQuery. So BigQuery is a serverless platform. No need to create any instance, any server, any environment. No need to worry about the configuration. No need to worry about the infrastructure. Anything, nothing is required, guys. If you wanted to work with BigQuery, you can directly go to the BigQuery and you can create the data set tables and functions, all of those things. And it is one of the data warehousing solution. So you can see here, guys, out of all of these things, see here one of that you have a most advanced properties such as columnar storage model, and it supports batch analytics for the warehousing. So and you don't need to create any indexes, and you don't need to create any kind of infrastructure server anything. So that is the reason it is called as a modern warehousing solution. So it is called as a modern because it got all the advanced properties. So that's the reason it is also called as a modern data warehousing solution. It is also called as a modern data warehousing solution. It's because of these options. It's a warehousing, so it's a serverless platform, and we can work with the large amounts of the data. No need to create the indexes. Follows the columnar storage model, which is very fast for analyzing the data, and batch plus streaming analytics. You don't get these things in the traditional systems. So that is the reason BigQuery is a modern data warehousing solution, which is highly scalable. Okay, and this is what is BigQuery, guys. So let me gonna show you one more time. Okay, hope you all can see my screen clearly. So BigQuery is a modern data warehouse, serverless platform, highly scalable. So when I say scalable, you can able to store any amount of data. So today you have stored some 100 GB, tomorrow you wanted to store 200 GB. Yes, It is scalable. You don't need to worry about scaling up and down. Also, automatically it is scalable, auto scalable. To work with large amounts of the data, we can go to the BigQuery. And here, what kind of a data we can store, sir? It is a tabular data and structured data. You can define the schema properly. Sorry, guys. So here we can store the tabular data and the structured data, which will be having the columns and rows, and we have to define the schema properly. And it comes up with the built-in query engine, which is capable of running the SQL queries. And you are going to get a very good performance. You can see here, we can able to manage the terabytes of the data within a seconds, petabytes of the data in a minutes only. See, you are talking about petabytes of the data. It's not about GBs. We're not talking about the gigabytes of the data, sir. It is next version, that is terabytes and petabytes. Even though when you deal with terabytes and petabytes of the data, you call the data as a big data, right? When you're dealing with terabytes and petabytes of the data, you are calling the data as a big data. So whenever you're dealing with big data only, it is matter of minutes or seconds only. Okay, and you get this performance without managing the infrastructure, without creating any indexes, without managing the infrastructure, without creating indexes. And one more thing, when it comes to the storage method, BigQuery follows the columnar storage model. Here, both the reads and updates are very faster. But when you go to the traditional systems, the data will be stored in the form of a row storage model, and it is mainly designed for inserting the data, only for inserts. Okay, so this is the main advantage, guys, for the BigQuery. It stores the data in the form of a columnar storage model. And one more thing about the BigQuery is that it is providing the support for both batch analytics as well as streaming analytics or real-time analytics. With the help of the BigQuery, you can able to perform batch analytics as well as real-time analytics, which is not possible in the traditional warehouses. If you go to the Hive, it doesn't support a real-time data insertion. It doesn't support it. So that is the main advantage with the BigQuery, is that you can go for batch as well as real-time analytics. So if you wanted to work with the BigQuery, the hierarchy of the structure is like this, guys. So in a BigQuery, you will be having a project ID. Under the project ID, you will be having the data set. Under the data set, you will be having tables, views, functions, and stored procedures. I will show you this one more, but just to get your idea, some idea. And what we can do with the BigQuery, if someone asks you, with the help of the BigQuery, we can collect the data, whether it is a batch data or streaming data. We can collect the data. We can store the data in the BigQuery. We can process or transform the data in the BigQuery. We can analyze the data in the BigQuery. Everything can be done in the BigQuery. Sir, I can collect the data, whether it is a batch data or streaming data. I can store the data. I can process the data or transform the data. I can also analyze the data in the BigQuery. So this is what is BigQuery, sir. BigQuery is one of the modern data warehousing solution. You can see here all the things about the BigQuery is that BigQuery is one of the modern data warehousing solution which is serverless and highly scalable. So when it comes to the BigQuery architecture, BigQuery has three main components, guys. BigQuery has three main components. Okay, so this kind of a question they're gonna ask you in the interviews. One is Colossus distributed file system. One is Colossus. Okay, this is the component one, and you have a component two, that is Dremel engine. You have a component three, that is petabyte network, that is Jupyter network. It is Jupyter. This is component three. Total, we have three components, guys. So in a BigQuery architecture, can you tell me what are the main components? So there are three main components in the BigQuery, guys. One is Colossus distributed file system. Okay, or you can call it as a just Colossus. And the second component is Dremel engine. And the third component is a Jupyter petabyte network. Jupyter network you can call. Okay, so look at here. What is Colossus, sir? Sir, it is a storage layer. Sir, in the Colossus, it is a distributed storage model. So what it will do? Whatever the data that you are actually storing in the BigQuery, it is going to be stored in the Colossus. Okay, that is the reason it is called as a storage layer. The BigQuery storage layer is nothing but a Colossus distributed file system. Also call it as a CDFS. So whatever the data that you are going to give it to the BigQuery, it is going to be stored here. First, it is going to be splitting it into the multiple machines. Whatever the data you give, it converts to the data and splits the data and distributes it to the multiple machines. Okay, so that is what it will do. And the next component is that the Dremel engine. It is called as a processing layer. So whatever the processing that you need, whenever you wanted to do some kind of a transformations or processing or analysis, all of those things will be happening here only in the Dremel engine. So Dremel engine, with the help of the multiple virtual machines or multiple compute options, it is going to be doing the data processing and data analysis. Okay, so that is what is a Dremel engine. Okay, it is a processing layer. And petabyte network, that is Jupyter. What it will do is that whenever you wanted to do the data processing, the data has to be moved here and there between the Colossus and Dremel. So to move the data between the Colossus and Dremel, Jupyter petabyte network is going to be working between them. And Jupyter petabyte network, the name itself, it is petabyte network. Petabytes of the data, and within a 1 second or 2 seconds only, it is going to be moving the data. Not even 1 or 2 seconds, it's in a milliseconds only. So that's the reason it is called as the Jupyter petabyte network. So whenever the data requirement data movement between the Colossus and Dremel is required, the Jupyter petabyte network come into the picture and it moves the data, shuffles the data between the Colossus and Dremel. Okay, so that is what is your third component. Okay, total we have three components, guys. One is Colossus distributed file system. Second one is Dremel engine. Third one is Jupyter network. Okay, so let me gonna mention here the names properly. So what happens? So it is Colossus, COL. Maybe small spelling may be wrong, but this is how it goes. So it is a Colossus distributed file system. Okay, what happens when you submit a query? So for example, what user will do, right? So they're gonna be mentioning some kind of a query, right? So select star from some table, or insert into some table, alter table or update table, whatever the query, or select statement, select star from some, whatever the query that you are running. Whenever a user submits a query, submitting means what, sir? Whenever a user click on run query, that particular query will be submitted to the Dremel engine for the processing purpose. Because you mentioned here, select star from some table where some condition you have given. So this is your SQL query. And that query, whenever you try to run it, it will be submitted to the Dremel engine. It will be submitted to what, sir? It will be submitted to the Dremel engine for the processing purpose. But when I mention select star from table, the data of the table where it is available, sir. If I wanted to do some kind of a processing, I need the data. Yes or no? If I wanted to process the data, we need the data, right?
Yes, sir.
So to get the data, what it will do is that where there will be a Jupyter network, right? What it will do, Jupyter network from the Colossus, it moves the data from the Colossus to the Dremel. and Dremel gets the data and it processes the query and it returns the data. It returns the output. So this is what happens, guys. In the backend, what it will happen is that whenever you click on run query, you write your query and you click on run query, so the query will be submitted to the Dremel engine, and for the Dremel processing it needs the data, so the data will be moved from the Jupyter network, moved from the Colossus to the Dremel via Jupyter network. Once it receives the data, and it is going to performing the query and it returns the output. So this is what happens in the BigQuery internal architecture. So this is what is BigQuery's internal architecture, guys. So this is what happens whenever you submit a query. Okay, it is having three layers. One is storage layer. So this is your storage layer. And this is your processing layer. Okay, so these are the things. So let us go to the BigQuery now. Let me go to the BigQuery. Why it is still taking this much time? Okay, let me go to the BigQuery. So this is how the BigQuery's interface looks like, guys. Whenever you click on a BigQuery, this is what happens. This is how it opens. Okay, so as I told you, you can see here I'm the focus on this area, guys. Now, so this is your project ID, yes or no? So look at here, morning bootcamp 6:30 is your project ID. Okay, so all your databases are tagged to the project ID. Under your project ID, you will be having databases and tables. So queries and notebooks and all of these things are like temporary purpose. You can remove it. But if you actually look at it, so this is how the model, working model will be. If you wanted to see, so this is how the working model will be, guys. So under the project ID, you can have data set. Under the data set, you can have tables, functions, views, models. Similarly, if you have one more data set, you can have a table one, table two, function, views. So that is how. So where your data sets are coming under, your data sets are tagged to the project ID, your tables are tagged to the data set. Okay, similar to the database. Okay, even in the databases also, you will be having your tables and all of those things, right? But here, every project has its own set of data sets. Every data set will be having its own tables. Okay, so that is how. Let us see. So, for example, I wanted to create data set. See here, data sets comes under the project ID. You go to the project ID, you click on these three dots. You'll be able to see refresh contents, and you'll be able to see create data set, right? Click on create data set. See here, you can able to see, you have to mention the data set ID. Sir, I wanted to go for data set ID as, let us say sample DB, or let us say raw data set. So this is how the data set name I have given as raw data set, or bronze data set. So the data set name I have given as bronze data set, sir. So and you should select again the location where this entire data and all of these things go. I am going with the multi-region, guys, and I am selecting the US multiple regions. Table expiration is something that once you have created all the tables under this data set, if you enable the expiration, after 10 days, all the tables will be deleted. If you enable the table expiration, if you mention some number of days, after that many number of days, all the tables under this data set will be deleted. Okay, if you think that, sir, I want all my tables to be deleted after 15 days, then you can able to delete it automatically. It gets deleted automatically. That means it gets expired automatically after 15 days. We don't want that now, so I'm going to disable this option. So you enter the project ID which is under this project. Sorry, you enter the dataset ID which is tagged to this project ID. Select the location properly. And if you want to enable the table expirations, you can able to select it here. So once you have provided these properties, click on create dataset. So that is how your dataset is created. Look at here. So this is your dataset which is comes under your project. Now tell me where the tables are comes under.
Inside data set.
Inside your data set, all the tables will be created. Sir, you can able to see this is your data set. You can able to click on this one and you can able to create table. Or we already know, so this is our editor, sir. So this is our editor. So if you wanted to create any table or view or anything, you can able to do it here. So for example, sir, I wanted to create a table. So what is the command, sir? If I wanted to create a table, can you guys confirm?
Create table.
Create a table.
Table name.
Table name. So that is actually the table name whenever you wanted to work with the traditional systems. But when you are working with the BigQuery, you are not just mentioning the table name, you have to mention the table ID. Okay, you don't mention the table name, just table name. You just mention the table ID. So when I say table ID, you have to mention properly the project ID dot data set dot, and then you have to mention your table name. So this is how you have to do it, sir. Okay, so the table name I wanted to mention is customers. Let us just say customers I wanted to create. Okay, so this is how whenever you wanted to create any table, you have to mention the table ID, sir. Okay, so you don't need to mention this thing, but you can see here if you don't mention it will be looking like this. You have to start the bracket and we have to mention the detail, right? So customer ID I wanted it to be int 64, and the customer name I wanted it to be string, and customer email I wanted it to be string again. Customer age I wanted it to be int 64, and gender you can go for string. Marital status you can go for boolean. Date of birth you can go for date time. Okay, so this is how. Okay, purchase date, timestamp. Okay, so this is how whenever you wanted to create a table, you mention your table ID. So this is what I call table ID, sir. I don't call it as a table name. I call it as a table ID because project ID dot dataset dot table name. Okay, project ID dot dataset dot table name. So this is how you have to mention. So if you wanted to differentiate it, you can use backquote. Guys. So backquote will differentiate your table name or a table ID from all other code. So this you can actually use backquote. Okay, so this is how if you wanted to create a table, you can able to create a table. Now this table comes under this particular project ID, this particular data set. So the table will be created. So if I run it, you see here the table will be created. Okay, here will you be able to see it? So here we have the customers table created. So this is how if you wanted to create any table. Sir, I wanted to insert some data. So if you look at the table first. So when I click on the customers table, you see here, guys. So we have the customer ID, name, email, age, gender, all the columns are there, and their data types. You will be able to see it here. Click on the details. So this is your table ID. From now on, whenever you want the table ID, you don't need to mention anything. You can just come here, click on this copy button. When it is created, when it is last modified, table expiration is there or not? No. And number of rows and the number of storage, that is storage. So do we have any data here? No, because it is a number of rows are 0 only. We have not inserted the data. So if you wanted to insert the data, I come here. So what is the insert command, guys? Can you guys tell me?
Insert into values.
ID values.
Insert into table name values.
insert into the table ID we have to mention. So the table ID is available here. Copy this thing and go here. Backward start, backward end. Insert into
Values
value, and we
and
have
the
to enter the
data
data,
columns.
right? So the columns are, okay. So the columns are here. So I'm gonna, you can also right click on it, sir. One more thing also you can do, because we wanted to see the columns only. So you can click on this one, right arrow, you can click on it and right split the right. So you'll be able to see it here, the command, and I can able to see the schema also here. So that whenever I'm inserting the data, so ID is an integer one, name is something like John. Okay, so let me go with the small letters all, and email john@gmail.com. Okay, and the next thing, age is an integer, you can say 29, and gender you can say male, and date of birth you can say some random date, guys, some whatever it is. The purchase date also you can give something like some random date. Okay, so this is how. So row has expected one. Something wrong? Did we miss anything? Okay, sorry. Marital status is missed. Your marital status is true. You can mention true. Yeah. And what is that? Gender is a string. Sorry.
Date also.
Date is also a kind of a string format. We have to mention. Right.
Sir, time is not a mandatory. Don't we have any time related to data type?
Oh, we have time here, right? The data type related to the timestamp.
Oh, okay.
Okay.
Yeah.
If you wanted to mention, so let us go with current timestamp. Okay. So the, if you wanted to go with current timestamp and current date, the date also I'm going with current date. Okay. So this is how two things we can use. Okay. So current date means the date, today's date will be taken. Current timestamp means the time with the current today's date it is going to be taken. Or else if you wanted to mention it, you can mention it properly. So something like 01 hyphen 01 2022. So this is how you can mention the date. Okay, could not cast literal. Okay, sorry, it is date, right? Yeah.
I think you need to put single quotes.
No, single quote or back quote, it should be same. There isn't any difference. It should be taken care. Sometimes if it is not taken care, what I will do, I will mention here date time. Okay, so I'll mention here. Okay, sorry. So I forgot that, guys. Actually, for the date, I think you have to mention date first. Okay, year first we have to mention, then the
Yes,
month,
and
and yeah, US, yeah. So this is how you have to mention. I forgot that. Yeah. So this is how the current timestamp also. If you wanted to mention current timestamp also, you can mention some date only. But if you wanted to 2022 02 03, and if you wanted to mention the time, so some 02 hours, 02 minutes, 02 seconds. Okay, or else 02 hours, 54 minutes, 32 seconds. So this is how the time you have to mention. Okay, so this is how you can able to, whenever you wanted to insert the data, you can able to insert it like this. Okay, click on run so that it will be inserted properly. I'm gonna left to tab it. So the data is inserted properly. So you can click on this table, go to the table. All the columns are here. Go to the details. You see here, guys, number of rows is 1. The number of storage is 61 bytes. And one more thing is that the preview is also there. Sir, if you wanted to preview the data, sir, I wanted to preview the data for sampling purpose. You can preview the data which is free. You don't need to worry about it, which is free. Okay, previewing the data is free. So what we have recorded, we have added only one record. So that is the reason we have only one record here. Whenever you have thousands, millions, trillions of the records also, you can able to see the data here. Okay, so that is how whenever you wanted to create any table, and you will be able to create the table under some data set, and you can able to insert the data, you can able to manage the data and anything. Okay, all of these things can be done here. Okay, so not only that, sir, I have created a table manually. Right, we have created the table and inserted the data manually. No, sir, I have the data in the Google Cloud Storage. Okay, assume that I'll go to the Google Cloud Storage, because we know that Google Cloud Storage will be having the data in the form of a files, right? So we have assumed that we have already here one of the file, that is students.csv. Sir, for this table, I wanted to create a, for this particular CSV file, I wanted to create a table in the BigQuery. For this CSV, sir, I wanted to create a table in the BigQuery. So to do that, there are two ways of doing it. There are two ways of doing it. Either you can click on this three dots, click on create table. So this is not a table, it is not an empty table. So try to understand this point, guys. Whenever you wanted to create a data table inside the BigQuery, there are multiple source it supports, and we can able to create multiple table types, and we can able to get the data from multiple file formats. Let me gonna show you all of those things once. So BigQuery supports these many sources, guys. You can able to get the data from the cloud storage. You can able to upload it from your local machine, Google Drive, Google Bigtable, Amazon S3 buckets, Azure blob storages. So if you have your file or a data available in any of these locations, you can select that location first. For now, I have the data in my Google Cloud Storage. So I have to select the file. So click on this browse button, and it is here. Selected it, and you have here students.csv. Click on this. So if your file is there in the Azure, you can select it, or AWS, you can select it, or Google Drive, or whatever it is, you can select it, or you can create an empty table also. That is also fine. And once you have selected the proper file, you can select the format. BigQuery supports these many formats, guys. BigQuery supports CSV file. Okay, look at here. How many file formats that the BigQuery supports? If you ask me, sir, BigQuery supports these file formats. Okay, so look at here. These many formats that the BigQuery supports, guys. Okay, data format. So it supports CSV, JSON, Avro, Parquet, ORC, backup files, iceberg file format. So these many file formats it is going to be supported. So these are the file formats. Okay, similarly, it supports multiple data sources, as I told you. So it supports these many data sources. Okay, look at here. It supports this many data sources. It supports data from the cloud storage, local machine, Google Drive, Bigtable, S3 buckets, blob storages. So from these many data sources, you can able to get the data and create the table in the BigQuery. Now, sir, I have selected the cloud storage, and I have selected the file, and selected the file format as CSV, because it is a CSV. You can see here, right? Students.csv. It is a CSV format. I'm selecting the CSV format. Once that, whenever you wanted to create any table, the tables will be tagged under the project and under the data set. So you select the table project ID properly, data set properly, and give a table name. I wanted to give a students table. The table name I wanted to give a students table. And there are two types of tables. One is native table and one more is external table. So native table, what is the difference between the native table and external table? Try to look at here, guys. In BigQuery, there are two types of table. One is native table. One more is external table. Native table, both structure, table structure plus data is managed by the BigQuery itself. So both table structure, nothing but a table schema, as well as the tabular data, both is managed by the native table. Just now we have created one of the table, if you guys remember. We have created a customers table. That was created by the, that was a one of the native table. It's because your table structure is available in the BigQuery. Your is also available in the BigQuery. So that is the reason it is called as a native table. In a native table, BigQuery manages both the table structure as well as data. So that is the reason it is called as a native table. The name itself, it is saying that table structure as well as data is in native in the BigQuery. Okay, so both is managed by the BigQuery only. When you go for the external table, only table structure is managed by the BigQuery. Okay, only table structure is managed by the BigQuery. The data will be in some other platforms, some other external storage layers, maybe in the GCS, maybe in the S3, maybe in the blobs, Azure blob storage. So that is called as a external table. External table means the data is external to the BigQuery. The data is external to the BigQuery. So either you can go for the external tables or internal tables. You can also call it as an internal table, native table or internal table. So in an internal table, your table structure as well as data is there in the BigQuery only. But in the external table, the table structure is managed by the BigQuery, but the data is external to the BigQuery that may be reside in the GCS or S3 or Azure blob storages. So this is the main difference, guys. Okay. Now look at here.
Sir, what
Yeah.
was the benefits like if we have this external table or native table?
So the
Any
benefit is
specific
that
reasons
you
there?
can, yeah. So when you go for the native table, the rate, the performance is very high. Okay, the performance is very high. But when you go for the external table, the performance is little lesser because you are not managed. BigQuery is not managing the data. Okay, and one more thing: when we go for the native and when we go for the external, so native tables are the projects where every day you wanted to do some kind of analysis on top of the data, right? So when you are managing the data in the BigQuery, so what you are trying to do, your data is there in the BigQuery for every day, and you can able to analyze the data every day. So where you wanted to analyze the data almost all the time or every day, every month, in that cases you can go for the native table. And it, and the next one is external table where, sir, I don't want it to do the analysis every day. So this is the only one time we wanted to analyze the data and we leave it. And whenever you wanted to analyze the data one time, why do you have to worry about moving the data? Right. So if you wanted to do the one-time purpose, one-time analysis or one-time processing, if you wanted to do such kind of a things, you don't need to move the data all the way from the external layers to the BigQuery, right? So why do you have to waste your time on it? So in that case, you can go for the external table so that you can able to just directly create a table structure and you can query that external data. Okay, so that is what it is. It is called as the external tables. Okay, so
Okay. And is there any cost related reason also? Like if you go for the
you
native
can think of
for storage?
cost is a secondary perspective. Cost is a secondary perspective. You can also think of that. So because assume that, sir, I am already paying some of the cost in the GCS because I have a lot of data, 100 GB of the data in there in the GCS, and I don't want it to move the data to the BigQuery. If I move the data, again 100 GB of the data in the BigQuery also. So you have a lot of data here, duplicate data. That means 100 GB data, we are paying the cost here, and 100 GB of the data when I move it to the BigQuery. In BigQuery also we have to pay the cost. So if you don't want that kind of a scenarios, you can go for that. But that is secondary purpose. Okay, main purpose is requirement. Okay, every day you wanted to do the analysis. If whenever you go for the every day you wanted to do the analysis, having the data in the BigQuery gives you a very good performance. Okay, so that is how it is.
Okay.
And when it comes to the cost is secondary. But if you wanted to focus on, sir, I have a very huge amount of data which we don't want it to move the data. If we try to move the data, it takes a lot of time and a lot of cost also. In that case, you can go for the external tables. Okay. Now I am selecting the external native table, or I'll show you external table how it looks like, because we have just seen customer table is the native table only. Now if I go for the external table, you can see here I have selected the external table. and we have to provide the schema properly. So we can add the column name, data type, column name, data type. Now what I will do, sir, I am going to auto detect the schema for now. For now, I am going to auto detect the schema, sir. It's not a good practice. What you have to do is that earlier how we have provided the schema for the customers, you have to provide the schema here also. Okay, so now what I'm going to do is that I'm auto detecting the schema. Once you have auto detected the schema, just click on table. If you have any options, you can able to see it is comma separated. Header rows to skip. We have a one header, right? You can skip the one header also. Click on create table. So something wrong. Okay, something wrong. Make sure go to the issues. I don't know.
Because of auto detect?
No, auto detect does not, because we have waited a lot of time for creating a table. So that could be a reason that it the status that might have missed it. So let us do one more time. Okay, let me go to this one. I selected the file. CSV, we are going to select it. Table name students table, and I'm going to go for the native table, auto detecting the schema. So click on create table. It is created, sir. Okay, click on students. Sir, it is not a native table. Okay. Oh, I forgot that. So I have a one more class, guys. I'm going to join there. Okay, let me gonna tell you 1 minute. So it is a table we have just created, and you have the details here. Okay, and you can able to see it here, the table. So the source details. So you do not able to see the data, and you do not be able to review the data. Okay, so this is how it is. Okay, so this is how you will be having your source data and all of those things here, guys. Okay, so we will continue the class. We will continue this thing maybe tomorrow. Okay, I'm going to stop here the session, guys. I forgot that I have one more session. Okay, so here we have the schema and details. So this is how we have to create the external table. I'll tell you tomorrow also the difference. Okay, yeah. I'm going to stop the session, guys. If you guys have any question also, I'll take up in the tomorrow's morning.
Thank you.
Yeah, guys. Thank you all. Have a great day. Bye-bye.
Thank you, sir.
Thank you all. Bye-bye.
Bye.